All right, so now we're here and back. Remember, a little lengthy notes, but that's okay because we're preparing for the test, being as thorough as we can so we can experience the most success on the test. So state if these triangles, three side lengths can or cannot make a triangle. We're just going to use the triangle inequality theorem again. We're going to take the two smaller sides, add them, and they must be greater than the third. All right, so 3 plus 5 equals 8 is greater than 7. So yes, it can make a triangle. Two smaller sides, 12 plus 21 equals 33. Greater than 30. Yes, you can make a triangle. 23 plus 34 equals 57. Less than 58. So no, dude, can't. All right. And then some just relationships with triangles. All right. Realizing that there's a fact where we'll write this quick fact out is opposite. So opposite of each other is longest side slash angle. So what do I mean by that? We're going to determine the longest side and shortest side. Well, angle C is the largest angle. So the longest side is BA. Shortest well, angle A, 35 degrees, is the smallest angle, so the shortest side is BC. All right, for this triangle, we're going to arrange the angles to form from least to greatest. All right, so similar thing, we want to go from least to greatest. Make sure you read the order you're going. So like 9, side 9 is this least, so angle Z is the smallest. 12 is the next smallest, opposite of angle Y, and then so on and so forth, and then we can conclude X is the largest angle. All right, now we got some mid-segments problems. All right, given that the following is a mid-segment, solve for X and Y. So let's do Y first. So remember, mid-segments are formed by joining midpoints. So this point's a midpoint, so boom, boom. All right, so this is like a unit 1 problem where both parts of the mid-segments, those are half the 4y's half that side of the triangle, 6y minus 1's the other half. Since they're both half, they can equal each other. Distribute, subtract 6y from both sides, we're going to get negative 2y equals negative 6. And then we're just going to divide both sides by negative 2, and y equals 3. Mid-segments are half of opposite side. All right, mid-segments are half the opposite side. All right, that means I'm just gonna multiply by 2. All right, remember I say I always like to multiply the mid-segment by 2, less likely to run into fractions that way. But if we're able to set this up, we're in good shape. Then it becomes similar, where now we're just distributing 2x plus 8 equals 4x minus 2. Subtract 2x from both sides. We're going to get 8 equals 2x minus 2. Plus 2 to both sides. We're going to get 10 equals 2x. Divide by 2. And 5 equals x. All right, and then number 12, we're going to determine the coordinates of the centroid of triangle ABC. So this is something we only kind of practice minimally, something very specific, but if you know what to do, it ain't that bad. All right, so A is negative 4, 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So left 4, up 6, boom, that's A. B is 6, 6. It's going to be in this corner up here. And C is 1, negative 6. Whew, these are far apart. So to do this, there's two ways. All right, a centroid. Remember, a centroid, we'll write some fun facts about centroid. It's the balancing point. So it always has to be on the inside of the triangle, balancing point. It's formed by the intersection of the medians. Medians they're segments that connect angle to opposite midpoint. All right. So what does that mean? I can do this the hard way, where I find the midpoint of each side. So like that side right there has a length of, I can count it really fast, of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the midpoint, I just count 1, 2, 3, 4, 5, boom. And then connect it. So that right there is a median. I'll even write that down. This next one will count down at 8, will count AC. So down how many? Right over how many? So it's down 12 over 1, 2, 3, 4, 5. See, this is when it starts to get a little messy. Now we're down 12 over 5. So I'm going to have to go down 6 over 2.5 right there. Connect that. And then similar stuff over here where BC is up 12 over 1, 2, 3, 4. So actually 1, 2, 3, 4, 5. So now I have to go up 6 over 2.5 again, right there. That's the midpoint. So like, see how it's kind of hard to do? Like this point, this is the bouncing point right there, but what's the exact point? I'm kind of confused. I can't be certain if it's a whole number, if it's a decimal. All right, what you can do is the formula right here, which I highly recommend using. I love this formula. It's a great formula. If you can recall that the bouncing point of a midpoint, or excuse me, the bouncing point of a segment is the midpoint. The bouncing point of a triangle is a centroid. All right, this is why the midpoint formula and centroid formula look so similar. Now I'm just going to plug in things. Negative 4 plus 6 plus 1 divided by 3. 6 plus 6 minus 6 divided by 3. And P is going to be 3 over 3, comma 6 over 3. So P, the balancing point, is 1, 2. All right, so you can do the medians, but I like the formula. Two ways to do the same thing. All right.